So we want to do 79 through 82 from 10.5? Okay, so 79 through 82 says we should use the fact that the load strength of a square box beam is related to its volume by this formula. S of V is, what does that say? So S of V is
750 V to the 2/3.
750 V to the 2/3 power. Okay. In this formula, V is in cubic centimeters and S is in newtons. Okay, so I think, all right, this is newtons, right? And V is cubic centimeters, right? Okay, so I should 79 evaluate and interpret S of 1,000. Okay, so what's S of 1,000? What am I kind of thinking about when they gave me this formula?
How big is the pipe that can hold 1,000 newtons?
Flip it. So this is asking for you to put in 1,000, right? You guys see that? So this isn't asking if 1,000 is the newtons. This is asking for if the volume is 1,000. What's the strength? You guys see that? The thing I'm thinking from this formula is that this thing's a rule, right? So pictorially, this is there's some kind of a volume place over here, right, for V's live. And then there's a rule that I've named S, right, that takes a volume and turns it into a strength. Okay, see that? So here I'm putting 1,000 in for the volume. I'm wondering what's the strength I get out. So if I'm going to evaluate this, I get, let's see, I should really just take this and stuff it in there for the V's, right? So what do I get out of that? I get 750
times 1,000 to the 2/3, or
okay, so 1,000 to the 2/3. Is that something I can calculate?
kinda.
Kinda.
Yeah, if it works out.
Okay, does it work out? How do I figure out if it works out?
It's 100. Because
Oh.
the cube root of 1,000 is 10. The square root is 100.
Yeah, so when you're doing this with a big number, right, it might be easier to do the root part first, than square it, right? So I might think about this as the cube root of 1,000 squared. Right, the cube root of 1,000 is 10. Squared is 100. So I get 75 what? 1,000. Okay, so that was the evaluate part, right? How do I interpret? What does this mean?
Steel beam. That's 1,000 cubic inches can hold a weight of 75,000 newtons.
Yeah, exactly. So a beam, right, with volume is 1,000 has a strength of 75,000. And really, if I was a better engineer, I would put units on both of these. So, what's the units on the 1,000?
Centimeters?
Centimeters
Cube.
cubed, right? And the units on my 75,000,
Newtons.
those are newtons. And if I was even better an engineer, I would remember that 1,000 newtons makes a kilonewton. Then I would say this is 75 kilonewtons, but that's all I'm not good at engineering. Cool. Does this at least make sense, guys? So the volume, 1,000, corresponds to the strength, 75,000. Cool. All right, so that was 79. What about, oops, I needed that. What about 80? 80 says if S of V is 750, let's see, so they gave me the rule, right? It was 750 V to the 2/3. And they're saying, okay, so for number 80, S of V is 750. Right? Calculate and interpret V. How am I going to get V out of this? How'd you get that? So close. So you said there's 750, right? And that's supposed to be what I got out of the rule, right? So 750 should be 750 V to the 2/3, right? So then to this equation, right, these two guys, both sides, what am I going to do? I want to solve for V, right? Easier first. So first things first, you want to get V by itself, right? So I divide by 750 both sides. So I get what? I get V to the 2/3 is 1. That one. So this has a cube root on it already, right? I want to undo that.
So cube both sides.
Yeah, so if I cube both sides, what do I get on the left? 1. What do I get on the right?
B squared.
V squared. Okay, then what do I do to both sides?
Square root.
Square root both sides. So I'll get plus or minus the square root of 1 is V. Yeah, exactly. The absolute value of V is 1. Which tells me V is plus or minus 1, right? Okay. But physically, do those make sense?
Negative doesn't.
Yeah, the negative one doesn't make sense physically, right? Because V was supposed to be a,
The volume.
yeah, it was supposed to be a volume. Volume should be positive. So I should get out of this V is 1. How do I interpret that?
One cubic inch of steel, whatever, can hold 750 newtons of strength.
Yeah, so a volume of 1 cubic centimeter, right, corresponds to a strength of 750 newtons. They really gave me that backwards, though, right? So really, maybe I should say, instead of a volume of 1 corresponds to a strength of 750, maybe I should say a strength of 750 corresponds to a volume of 1. Okay, see that?
When we do look at the -1, what would that be technically, even though we don't use it? Because the number's still there. So would it be like a weird form of antimatter or something, not saying specifically that?
That's a possible interpretation. So physically, right, my domain on my function is limited to positive volumes, right? So that other thing is just something that didn't fit in the domain. This is sort of the mathematical model versus the physical reality problem, right? If you wanted to make a reasonable interpretation, it might be if you had a beam made of anti-steel or something. But really, there isn't a physical interpretation back here. Does that make sense? Okay. Do we want to do 81 maybe? I think we could try that. So 81 says, if volume is increased by a factor of 8, determine the factor of strength increase. So if V turns into 8V, right?
Is this one for 81?
This is 81. Yeah.
Okay.
So if V turns into 8V, then S turns into something, right? You guys see that? Okay, so let me think. What if I plugged 8V in here? So I'd get S of 8V, right? Should be 750 8V to the 2/3, right? Okay. Now I might say, all right, so that's 750, and then I could, what? Yeah, I really should take the cube root of 8 and square it, right? So if I take the cube root of 8, what do I get? 2. I square it, I get 4. So there's a 4 here, right? And then there's a V to the
2/3.
still 2/3, right? Nothing I can do with that. And then I notice, oh, this guy, right? This stuff, that's the old S of V, right? So this is 4 times S of V. You guys see that? So if the volume goes up by a factor of 8, S goes up by a factor of
4.
So it's 3,000.
see, so yeah, it's 3,000 V to the 2/3, or what I really want to think here is it's 4 times as much as the old one. So if V goes to 8V, then S goes to 4S. Does that make sense? So when they ask, determine the factor by which the strength is increased, 4 is the factor by which the strength is increased. You guys know that everyday application of this? It's not beams. No. So the similar thing that happens to you every day is when you're driving your car, the kinetic energy in a moving object is mv squared. You guys know this? Probably not.
No, I didn't know that. I haven't quite moved up to,
So yeah, if you're going into it, you're gonna do that, right?
Yeah, so let's talk about it. Oops, not that.
I think it's.
So the everyday thing is this. Kinetic energy is a half mass velocity squared. Okay, so this is really just a way to turn a mass and a velocity into an energy, right? Cool. Why do you care about the energy? Because it goes somewhere, right? So the application of this is if you hit something, right, that energy goes somewhere. That energy is usually into you, right? As the driver of said vehicle, you care about that energy because that's how hurt you get in an accident. Okay? So if you're going twice as fast, how much more is it going to hurt?
Twice as.
No. This is the thing. It's not twice as much.
It's half.
No.
Okay.
So, in other words, if I think about what happens when V turns into 2V, right? Well, if I put 2V in here, I'm squaring it. So I get, instead of KE, I get 4KE. If I'm going twice as fast, there's 4 times as much energy in the collision. Okay, see that? This is why a head-on collision is a lot worse than a one car. It's not that their energy adds, it's that their energy is multiplied by a factor of 4. Okay, see that? This is not goodness, right? So this is the difference between a collision at 30 and 60 is not twice as hard to hit, it's 4 times as hard to hit. The difference between a collision at, how about this? What's the difference 20 miles per hour to 60 miles per hour in kinetic energy?
90.
Yeah, there's a factor of 3, so I square it. I get a factor of 9 in the kinetic energy. So, hit, 9 times the hit.
So you're only going 2 miles an hour and the other car's not moving. How much energy is actually, it's 4 times what? 2?
So how much energy is, really, I'm talking about the base, right?
Yeah.
So what's your base speed?
Say it's 2 miles an hour.
Okay, so then if I hit it going 4 miles an hour, twice as fast, there'll be 4 times as much energy. If I hit it going 10 miles an hour, there'd be 25 times as much energy. But it's always compared to a base, right?
Yeah.
So here I'm comparing this amount of energy at 20 to this amount at 60. If I wanted to actually work out how much energy there is, I'd need another equation.
Oh, okay. That's all right.
Yeah, and it's infinitely times as much as if you're not going anywhere, right?
Easy to solve.
Because if you're not going anywhere, you can't hit anything, right?
Right. Well,
So
it
it-
hits you.
Yeah.
I backed into somebody, or not backed into, I rolled into somebody going at 2 miles an hour, but it hit like hard,
Mhm.
but there was no damage. And she was upset, but I don't think she was hurt. I mean, she said she wasn't hurt.
And if you had hit her going 10 miles an hour, right, 5
Yeah.
times faster,
Yeah,
there would have been 25 times as much whiplash. Right, so I think you're probably safe at 2 miles an hour,
I'm
but
hoping
10 is actually not an inconsiderate amount of energy.
it hit.
Yeah, like think about how much it hurts to walk into a door.
Right, you barely, like,
You're going 2 or 3 miles an hour, right? And you're coming to a dead stop. If you're thinking about 5 times as much energy as it takes walking into a door, that's when it can start to hurt. When you're talking about the difference between 2 and 60, right, you're talking about 900 times more energy.
it's double and then times 4.
Or